All right, so in trig we solve for the ratios of the triangles using SOHCAHTOA. And so I gave you a copy of this thing. It's called the unit circle. So the unit circle is called the unit circle, and you've written down the values. So I don't know. You don't necessarily need to write those down. You should have it in your notes somewhere. You could write it down again if you want. Truthfully, I haven't memorized the unit circle. That's a lot to memorize. What I have memorized are the triangles. So the unit circle essentially is a circle where the radius equals 1. And so over here, if the radius equals 1, and then I have some corresponding x and y value. Well, on the unit circle, x comma y is the same as sine and cosine, and here's why. Remember that sine of theta is equal to the opposite over the hypotenuse, but on the two-dimensional Cartesian plane, that would be the same as y over r. But on the unit circle, in the unit circle, y is just y, but r is equal to 1. So sine is equal to y on the unit circle. And I said that before, but I mean, I wouldn't be surprised if you guys don't remember all that. So then cosine of theta, same thing, except it's the adjacent over the hypotenuse, but on the two-dimensional Cartesian plane, it is x over r. R is equal to 1, so it's really x over 1, and so cosine is x. So that's where this x comma y on the unit circle only is actually cosine of theta over sine of theta. Okay? And one little thing I might want to add, remember this identity that we talked about before? Tangent of theta is the same as sine of theta over cosine of theta. So if you know that, and you know your two triangles, one other thing I'm going to put in here, the triangles are important because that's where you get these angles from. So if I draw a triangle that looks like this, this is 30 degrees, but 30 degrees in radians is pi over 6. Okay, so this is our 30-60 triangle. So if this is 30 degrees, then this is 60 degrees. But remember, well, don't write it that way. We'll try to leave it in the triangle. Remember that that is pi over 3. And so the ratio, this is how I always remember it. 1 to square root of 3. Always. Okay? And then we have one more special triangle. All of your problems will be rigged up using these two triangles. Well, most of the time. We had the 45-45 triangle. And that triangle is like this. It's an isosceles triangle, where this angle is 45 degrees, as is this one. But that's also pi over 4 if we do the conversion. And the ratio there is 1 square root of 2. And those values, you memorize them, but those values are based on the Pythagorean theorem, right? A squared plus b squared equals c squared. And these are two famous triangles in trigonometry. If you memorize these triangles, I could fill out this chart off the top of my head, knowing the reference angles. And it seems like a long way to do it. But when I learned trig in college, my professor said, "Dad, you could memorize all these values, but man, that's a lot of stuff to memorize. It's probably just easier to memorize the two triangles and then apply the two triangles." So we're gonna try that and see. But I will let you use this unit circle on the test. So essentially what you're gonna do, we're gonna do example 1 in just a second, but they're gonna give you a measurement, wherever that measurement is. I don't know, 135 degrees, 150, wherever it is, you start here and you rotate around. That's going to form a triangle wherever you land. This is an x value, but this is a y value. But on the unit circle, this is actually cosine of theta, and this is sine of theta. All right? And then if they ask for tangent, you know that tangent is the same as sine over cosine. Okay? And we're going to use one of these triangles, because if you notice, you either have 30 degrees, 45 degrees, or 60 degrees. And then the unit circle stuff, because cosine is x and sine is y, when you get to the 90-degree increments, 90, 180, 270, 360, we're just going to use the x comma y values, which are actually cosine and sine. That's where all these values come from, right? So we'll just kind of talk about this briefly, but 45 degrees, which is pi over 4, cosine of theta, what's cosine of theta? Well, it's the adjacent over the hypotenuse. So if this is my angle theta on this triangle, which is 45 degrees, the adjacent is 1/2, or not 1/2, 1 over the square root of 2, but then you have to rationalize the denominator and you'll get the square root of 2 over 2. That makes sense? All right, so let's just jump forward and we'll do example number 1. So for example number 1, I'm going to want to go to 7 pi over 4. So that's right here. You see that on the unit circle? And really what we're doing is we're drawing a triangle right here. There's a reference triangle. The angle itself, though, 7 pi over 4, so this is the actual angle, and then this right here is our reference angle. Okay? But we're saying that x, well, let me do this in a different color so you guys don't get confused. We're saying that x comma y on the unit circle is the same as cosine of theta comma sine of theta, because it's on the unit circle. So the values then here would be, for sine it is negative square root 2 over 2. For cosine it is positive square root 2 over 2. Oh wait, they're not the same angle. We got to come back to that. Okay, so that's negative root 2 over 2. Now, one way to look at that is I know that this is a 45-45, right? So in my mind, I could go, okay, my reference angle is 45. I know that this is 1 root 2. But this is really negative 1, right? Because it's in the fourth quadrant and our y value is negative 1. In other words, when I get here, technically this would be 1 comma negative 1. That point right there. So you might say, well, Mr. Adams, how do you get the negative root 2 and all that stuff? Well, if I were to calculate sine, I would say sine of theta, it always reduces down to the same value, so it doesn't matter. So this would be negative 1 over the square root of 2. hit the top and bottom with the square root of 2. And so you get sine of theta equals the square root of 2, negative over 2. Okay? Let's do another one. So now we'll do this one, cosine 5 pi over 6. So we just find 5 pi over 6. It's right here. Again, this is our angle. This is our reference angle. Cosine is the x value. So immediately I know that that is negative square root of 3 over 2. But what's this reference angle? Well, really that's the reference angle of 30 degrees or pi over 3. So right here, this is 30 degrees or pi over 6. I'm sorry. I said pi over 3. It's really pi over 6. So remembering that this is 1, 2, square root of 3, but because it lives in the second quadrant, my x value would be negative. So it's negative square root of 3. So then I say, well, cosine of theta is the adjacent over the hypotenuse, which would be negative root 3 over 2, right? Because this is the opposite. This is the adjacent, and this is the hypotenuse. Now, sine's a little, or tangent's a little trickier. You've got to remember that tangent of 3 pi over 2 is the same as sine of 3 pi over 2 all over cosine of 3 pi over 2. All right, so 3 pi over 2 is 270 right here. So remember that your x value is cosine, so this is 0. We're going to double check this on a calculator. So this is 0, and then our sine value is negative 1. So tangent of 3 pi over 2 is actually undefined. Okay? So let's double check all these values on our calculators. Now, your calculators probably, well, if you didn't grab one, that's okay. Just look up here on the screen. They're on the bookshelf. So let me do the first one. I'm going to, first of all, on these calculators, you have to put it in radian mode. So you would scroll down here and go to radian mode. Mr. Adams already did that. And I'm going to say sine of 7 pi divided by 4. And I'll get negative 1.14. Actually, it'd be divided by 2, so this is correct. So if you get a decimal and you say, well, how do I know that's the right answer? You just go negative square root 2, right, divided by 2. And you get the same thing. That's how you double check it. Okay. So now let's do cosine of 3 times pi divided by 2. It's 5. That's why. Woo-hoo. I was doing the part C. All right, there we go.
It's over 6.
Oh yeah. I'm kind of clumsy today. Good thing you're here and you know what's going on. There you go. I knew the answer was wrong because it's really 1.73 divided by 2, which is 0.866. So that's correct. So let's see. The square root of 3, actually I need the negative in the front. Negative square root 3 divided by 2. Okay? And then lastly, we'll finally get to use that 3 pi over 2. that I've been trying to do. All right. So now we got an error. Now the reason we have an error is because